Hello everyone, myself Nitin Prakash Patil. I am assistant professor in Department of Computer Science at Savitri Bai Phule. This particular demonstration will be dedicated for how exactly deadlocks can be taught through an experimental demonstration. Now, to do so, I'm going to make use of PostgreSQL on the Linux operating system. Now, agenda would be we'll revise first the definition and maybe the necessary conditions, and then I will try to demonstrate deadlock using PostgreSQL. Now, some assumptions are there or prerequisites that I'm assuming over here are like the basic database concepts are known. SQL syntax also is known. Basic concepts related to process and transaction or lock management are known, as well as hands-on knowledge of PostgreSQL software using PSQL client is mandatory. Now let us start with the agenda. In databases, a deadlock occurs when two or more processes have resource lock, and each process requests a lock on the resource that another process has already locked. Now, when this happens, neither of the transaction here can move forward as each one of is waiting for other to release the lock. And then we do see a situation as deadlock. Now we know that there are necessary conditions. The first condition is said to be mutual exclusion. Now, when only one process is trying to access, then it should be the only process which might be permitted to use the resource at a time. Hold and wait is another one, where a process may hold allocated resource while awaiting assignment of other resources. No preemption, no resource can be forcefully removed from a process holding it. Now, when we do talk about these three conditions, these are necessary but not sufficient for a deadlock to exist. For a deadlock to actually take place, a fourth condition is required, and that's what is circular wait. Now, in circular wait, what happens is a chain of processes exists such that each process holds at least one resource needed by the next process in the chain. Now, let us try to see the scenario, deadlock scenario using PostgreSQL. So what I'm assuming is like I do have two relations created. One is student, subject, another is subject. The student has attributes roll number, name, gender, degree. Subject has subject, code, title, credits, degree. Now let me think of this. Suppose I started two transactions. Now when we, as I earlier mentioned, one should know the process management and one should know PostgreSQL sys. So we are going to access from two different terminals the PSQL client through the PSQL client the database. And let us assume that we have created these two relations over there. From process A, I'm into say transaction one or one first terminal. I'm going to access student through an update query. Okay. Now from terminal 2 or process B, what I will do is I will try to access subject through an update query. Now in third case, like what I'm going to do is I'm going to request from process A to modify the same table called subject, which is added, which was rather updated by process B. And at the same time, I will request through process B update request for a student for the same record, which was actually under lock or under control of process A. Now, if we see this scenario, this is same thing like what we discussed as in circular wait. Here, option is what? System can wait infinitely. But this cannot be an option. So what happens is PostgreSQL will abort one of these transactions after some time. And that's what is a parameter. There is an environment parameter set called deadlock time. Okay, now let us try to see this scenario through the practical demonstration. So I'm assuming that like I have created here two relations as I mentioned earlier. So this is one particular file where I have written some insert statements and the create table queries. Fine. So let me execute these queries. Say I'm having these two terminals open. Okay, these are the two terminals that I'm assuming process A, process B, whatever in vice versa. So let me say this is PSQL. I'm firing PSQL from all three things, all three terminals. Now let me execute that file which I created there. So the name I have given there is ACMTC. Now if I see, I have records. I select start from student and select start from subject. Okay, now as I have to start the transaction, so I will fire transaction start command called to begin. And the second process as well, I will start with transaction initiation with begin. Now what I will do is I will fire an update query. Update. So let me take this update, which I already wrote. So I will write this update subject set credits to 5 where subject code is CS1. Let me say I'm firing this. On the similar line from this terminal, I will fire another update. Update student set degree to IMCA where roll number equal to 21101. Now you may see both the instructions executed, but as the transactions are not committed. So if I see the records were intact the way that they are there. Right? No change has been made yet. Now, when I fire another update from here, right? So let me update this to, like, for example, 21101, we had MCA. Let me make it to MC. Now you may see that as this transaction already have an control or already locked the record by executing this SQL statement. Now it is not, as it is not releasing that, so this is waiting. And until and unless that lock gets released, this would not be executed. Same case, let me fire update from here. And I will try to access the same record and I will try to make the number of credits here. So let me go here and make the change. Now you may see, like what happened was after some time, as both the process were in waiting stage, it showed us an error. So let me try to copy this error and let me show you that error in font. Deadlock detected. Now, when this happened, the thing that I was talking about, you must have seen, like it took some amount of time rather to show this error, deadlock detected. And it is telling us like one of the process waits for a share lock on transaction, which was blocked by some other process. Similarly, that process 958 waits for share lock on transaction, another transaction number blocked by that 64, 960. And that's the reason while updating this tuple in the relation subject, when this got fired, ultimately the deadlock showed. And this is how rather the deadlock can be demonstrated through some practical demonstration. So one can create multiple scenarios like this. Here I took only two tables. You can have multiple tables. Now, if I go back and try to see like what exactly the changes are made. So if I see subject, you may see no change was made. Okay, but if I see student, what are the requests that we gave? IMCA. Okay, for this particular student, the record, what are the request that was made by us, say this terminal. Earlier we said that like we requested for IMCA. Okay, for this 21101. This is kept as MCA. And from here we fired this. So as none of them got executed, this is not committed yet. If I commit this, then only, but this transaction was already aborted because deadlock is there. This change, whatever the update that we made, will never get into action. But if I really write here commit, say for example, let me try this. Let us see now what happened. Let me fire student. You may see this record got updated. Now with respect to second table subject, if I see this got updated because there is no control, no lock available because the lock which was supposed to be there with this particular transaction was actually got released because deadlock detected. That process was running, but the transaction got aborted. Right? The queries which were said to be updated, though this might have been updated earlier, but when we fired this update, second update, that actually got changed. That MSc, okay, that of that particular student MSc, that might have been done, but ultimately it was not saved, and that's how the deadlock scenarios can be shown. Thank you. Have a great day.